Good morning. Today we're going to be looking at using JUnit and talking about the ideas of what unit testing or testing your code involves, and specifically using that for Java here in class. We've got a bunch of vocabulary we have to address when we're talking about testing. So we have a few things over here on the left. We have JUnit, which is the actual testing structure we'll be using. Assert, which is what we were verifying. We have our test suite, test and case, which are the two different types of things we'll be doing. And the test suite refers to a collection of tests, and the test case is a specific test for a class itself. We also have import static, which we'll be addressing, which is how we'll be dealing with the imports required when we're using JUnit in class. We have some at modifiers that we'll be using on this. These are some things we actually identify which specifically are going to happen with our tests inside this, since we have at test, at before, at after, and at suite classes. And we'll be taking a look at those as we go through this. We want to make sure we have our packages used so we can keep our code that is used together, have it together in this, and for our tests we'll put all of our tests in a single package so we can keep them integrated and can test all different components of our project as needed. We use a standard project prefix that we're using for whatever project we're working on, and then a .tests to indicate that it is the testing package. The test suite is our next thing. The test suite is what we're going to be doing to run all of the tests. We can test individual tests or individual classes as we like, but so we can have every single test run for all of the classes involved, all the test cases. We'll be using a test suite as well. And we'll use that for the idea of the name of the project, test.java is the naming convention we'll be using for that. Our test cases are the individual classes that we'll be testing at a time. So every class will get its own test case, and everything that needs to get tested will have tests within that individual test case. And the naming convention we'll be using when we're dealing with test cases will be the class name test.java. So again, we have just some basic naming conventions we'll be using when we're dealing with testing, and the idea of some structural components we have where we have the idea of a test package, and we'll use that. Here on the next slide, we see the testing structure as an example right here. We have our chat.test for the chatbot project. We have the package name storing the actual name of the project, chat, which is the prefix we've been using for this project, and then .test indicating it is the test structure for that. Every class being tested gets a test class. We have chatbot test.java, chat controller test.java, chat frame test.java, and so on. And then we finally have the idea of chat tests plural, which will be the name of the project, our chatbot, and then tests plural to indicate it is the test suite for the entire project. We also notice down here in the bottom left-hand corner, we have the idea of our JUnit library. This must be in our project so we can actually run and use the JUnit tests inside our project. And when you actually add the test suite inside Eclipse, it automatically puts it in there for you, so it makes it really easy to get that done. But if you have any errors with your tests so that they can't run at all, the first thing you'd be to check is to make sure that the JUnit library has been added to your project. You can also add that by right-clicking on your project, choosing Properties, going then and adding that library to it. So we have our testing sequence. The testing sequence is how we're going to actually go through every single test inside the test case. And what will happen is we'll have setup run. And notice that this is set up, so it's a two-word thing, not just setup. So we have the idea of our mixed case notation we've been using all year long. And setup runs before every single test. So setup will run many times inside every test case. Then whichever test we're working with, in this case, some test will run. And then we'll call the tearDown method, which will run after every single test. This structure happens repeatedly so we can have a clean set of data every time we run the test. So we want to make sure that we have our setup and tearDown methods properly coded so we can actually go through and use them properly so that every test when it runs is ready to go. In traditional Java, the actual sequence of methods, etc. that we see inside our Java file does not matter. However, JUnit runs them in a top-down fashion. So we want to make sure that when we're writing our tests, that we write our most basic tests first, and then we go down and add more complicated features or more advanced features or things that are dependent as we move further down the test list. And so we want to make sure, like I said, we test our basics first, aka we have our chatbot constructor test would be the first thing we would test. Then we check the components of things that happen inside the chatbot constructor or methods that are dependent on the constructor, and then go down and check every method from there on out. We have our JUnit setup method. We have our at before notation, which is the indicator that this is going to be running beforehand. This is part of the actual import itself. It knows that tells the compiler and the Java virtual machine to do this before anything else, because as part of that library that is part of the JUnit 4 library. And this needs to be happening before every single test happens. Like I said earlier, we're going to call this multiple times. And this is kind of like the idea of a constructor for the tests, where we can initialize any values we need to be using in all of the tests. We can have that stuff set up immediately and ready to go so that the tests can call or access specific values as needed within the actual test itself. So this will take the purpose of a constructor, just like the onCreate does as a method inside Android development. The JUnit setup method will act like the constructor for all the tests, so any initialized values that must be used in multiple tests can be initialized for us at that point. We also have our tearDown method. The tearDown method is prefixed by the @after notation, and so this is obviously going to happen after the tests occur. And this is where we clean up our objects, aka this is what we're where we deinitialize any values, or we initialize them back to null. We set things to be equal to 0 or false for default values and for primitive values. Any strings or anything that we'll be using, again, we set back to the most basic default values so that when we initialize them again in our next setup method, all those pre-initialized values have been reset to the most basic or null value available for them. And so we'll be doing this again multiple times, just like the setup method. This one happens, however, after every single test. Now, import static is something we've not used before when we're dealing with our imports. The import static structure is a way that we can actually have imports happen in a special occasion, so we can, instead of calling the class that we'll be using repeatedly for our static methods, we can have it so we can simply just call the method itself. And this is very useful in cases of JUnit because we have a lot of methods we'll be calling repeatedly, or if we have a project that does a lot of math for us, we don't have to call math dot, we can simply call the associated method attached to it. And so we'll be using this with JUnit Assert.sum method or math.sum math method. And so this, again, it's the idea of making it so we can have a little bit less code, we can have everything, so we can simply call the sum method, our test method, asserting it right through there. So we have the sample here of the import static in action. So we have import org.junit.assert, and so that's the traditional way of doing an import. In this case, we have to call assert.fel for the not yet implemented in the test chat panel method. However, if we use the import static method we have up here in the top of the right hand section, where we import static org.junit.assert.asterisk, we have the ability to import statically that assert object or class, and instead of having assert.fel, we can simply call fel. So it doesn't save us a lot of code, but it does make it so we can simply have a little bit cleaner structure and looking at these specifically for these static methods, things that can be called without making an instance of the object. We can simply just refer to the method itself. And since everything in here is going to be a test, everything is going to be prefixed by assert, that assert does become a bit overwhelming at times. So we want to make it so our code looks cleaner as we go through it. We have our assert method structure. All the assert methods that we'll be using within the JUnit testing will have the same basic structural approach that we're going to be using for them. As you can see right here in the assert same, we have a tested parameter and an expected parameter, which we expect to be then that the first one is the same as the second one. Looking at our assert null, we can have an option for a message as a string, a parameter, and the expected parameter. And so we are assuming that that it works for null. We assert same for tested double value, accepted double value, and the acceptable difference. When we're dealing with doubles, remember, since we can't check for exact equality, we have to have a delta or a difference that's attached to them. And so we have the idea of some basic structure, and most of the JUnit methods follow this structure for all of them. It's just a quick way to idea that we have our first parameter and our second parameter. The first one is what we're giving it. The second parameter is what we're expecting it to be the same as. And in the case of doubles, we need to make sure that we provide a difference or a delta between the values that is acceptable. So when we do our subtraction or verification of what the difference is, that we're okay on that. Our basic assert methods that we'll be using, we have assert equals or assert not equals to see if these values are the same. Assert null, assert not null, passing as a parameter to see if it is of an actual value or if it's simply null. We have assert same, assert not same, checking for the idea of the same contents within something. Assert true and false, pretty self-explanatory there. And we have the force fail. The force fail happens quite often because it's the idea that we are going to have a default test sometimes, and we want to make sure that if we tell it to fail, it should fail. We want to make sure, again, when we're dealing with test-driven development, sometimes the first thing we want to do is we want the test to fail before anything happens, and that's a quick way we can do it, is by passing it a fail with a message to go with it. We want to look at how we can test. Now, what we have to do when we're deciding how to test something, the first thing we have to do is identify what are the expected results. Is there going to be a changed value? Are we building an object? Has something been occurred in that makes some modification of other existing objects. We just need to actually take a time to actually identify what is supposed to be happening because of either this method or constructor or object in use. We want to make sure that we then match those results to the assert statements that we would actually test within it. Assert this is the same as that. Assert these values are equal to each other. Check to make sure that we have the same parameters for all the things, or we have the same order of sequences inside an array. Making sure that we have everything that we need to have is what we're going to be doing for that. So we need to identify what should be done first. Again, this goes back to that principle we've been using all year long, that design is important. We need to plan what our code should do before we actually even write our code. And this is a continuation of that. We also can have multiple asserts per test. We're not going to simply just do one-line methods. That's a waste of our time and our effort and our energy. And so when we see our methods, our test methods inside our test cases, then we will see probably multiple asserts. We'll be testing a bunch of different things. Each method does one thing, but that one thing will probably have multiple implications. And we test for each of those different implications with multiple asserts inside each of our test case methods. Now, to save some reality, we're not going to actually take the time to test our getters and setters. Just like we've not been providing documentation for our getters and setters inside class, we're not going to test them as well. Simple, one-line, basic principle of Java things do not need to be tested by default. This dot something equals something. There's no reason that should provide any error or anything like that. And we can take the time to simply not test that because we can assume that's okay. If there's more complex action happening in a getter or setter, generally there shouldn't be, then that would be an acceptable time to write a test for it. But if it's simply returning a value that is with no calculation, just returning a straight data member, no calculation attached to it, there's no reason to simply test a getter or a setter. We have right here the sample default test. Again, we have the idea of @test, that indicator right there, that it is a test itself that tells JUnit that this is a test and it should be executed in the order it was seen. We have our standard public void we've been using all year. It's a public method. It can be seen externally, and void, nothing comes back. In fact, all of our test methods will be void methods. A method is prefixed with the word of test, and then what we're testing followed afterward. Standard set of squiggles, and in this case we're passing it fell, and the message we fell with is not yet implemented. We haven't written a test for it. And in fact, when you use JUnit to build your own tests, this is what will be populated automatically within that. Here's our sample chat frame test. This is an example of how to test a GUI thing fairly quickly. We have our private chat frame object. We have to do some standard declaration of private data members so we can use them as necessary. We have our setup method. In our setup method, we'll throw an exception because in order for it to start up, it has to have the ability to crash itself without crashing the entire system. And so we have in this line, we have a base frame as a new chat frame, passing it a new chat controller. So the idea, it's acting just like the idea of a constructor for an object. It initializes the required data members for the test. And then we have our @tearDown, we set that back to null. So again, we are creating an object and nullifying that object as part of our standard structure. We have a couple different tests attached to this. We assert not null, that base frame is not null. So we're making sure that our frame itself is existing when we check our constructor. So after it's constructed, we should have assert not null passing at base frame. We also want to attest that the getContentPane has a right value. In this case, we assert true that baseFrame.getContentPane is an instance of a chat panel. So we're using the idea of that instance of, that keyword that tests for making sure that the object that's being returned from that is an instance of another object. So we can check the inheritance pattern with that. So we can make sure that we have the right kind of thing inside that. And this is where we have the idea that we're going to make sure that our code always works. Standard use of squiggles for the class itself, and we're good to go. We have a couple different ways of doing tests. The first one that we have is the idea of what method test types we have to actually write. If we're testing a return type method, something that returns a Boolean, an array list, an array, a string, a car, a monkey toast, any single type of thing, one of the first things we want to write for a test for is making sure that the correct value has been returned. Making sure that we actually are calculating a value that's an acceptable range, looking at our design of our code, making sure we're not returning -5 when it can only be a positive number, making sure that we have the right sequence of strings or something like that if we're using an array list or an array, checking for that basic thing that's coming back from it. That's the first thing we want to actually check or write an assert method for, or that if we are running tests, that's what we're going to be looking for specifically in that, is making sure that what's returned from that comes back and is properly used. However, if we have a void method, obviously we don't have something we can just return back and get. And so in that case, we want to actually look at what does that void method do? What is accomplished by running this method? And in that case, we then identify what are the effects of this. And so we test what is affected by it. If a void method, say for example, changes the name of all of the users by adding the suffix of to every single user, then we would have a method would check to make sure that that string is attached to the .name method of every single user of that program. So we have to have the idea that we are finding some affect, something that's impacted by that. If nothing was impacted, there's no reason for the method to occur in the first place. So we make sure that we identify what is being used by that method so we can actually test that impact and write a test for that. We also have in the way of testing types, we have private methods. Now, obviously, if a method is private, we can't test it in another class. We can't call it. However, we can do the same thing we did with the idea of a void method. A private method can be tested by testing the impacts of what that are. So we can use the getters or setters of a private data member, or use the impacts of what is changed by that private data member, by that private method. We can check what happened. What was the impact of that private method running? Because we know, for example, that method would be called inside a constructor, or that method is called inside some other method as a helper method. We would call that method and see what impact happened and test that. So we can always measure some impact. Even if it's a private method, we can always test and measure that it's running properly. The next thing we have is the idea of our constructor tests. Again, this is the first thing we're going to look at that and making sure that something is not null. When something is initialized, obviously null should not be around. We also can make sure that the correct data members are initialized and initialized with the correct values. Again, by using the idea of testing what is returned from the getters and setters, making sure they initialize for the correct values and that they can then be used appropriately throughout the project. So again, we look at the idea that when we're testing, we make sure we identify what the impact is and test that, look at the return type and the initialized values, and make sure we watch for all those different components. Why do we do testing? Well, one of the biggest reasons is we want to have the idea of good coding practice. Let's make sure that our code is going to be both stable and secure. If we test everything all the time, making sure that our code is stable and secure, our code is less likely to crash, and we know what's going to happen as our code is running, regardless of what actually impacts it. Then we also have the idea of test-driven development. Test-driven development is something where we have the idea that it's one of the many businesses and companies use this right now, where we actually write tests before we write any code, which means they're going to automatically fail. And then we write code that'll pass the test that we know that it needs to do. So again, it takes that principle of design. We know the design of what we want to have happen. We write a test that will make sure that it will pass what would make that design principle pass. We then run that test, it fails, and we write tests that we write a code that will pass that test and repeat it as necessary. So again, you're writing lots of tests and lots of code after you've written a test that would pass once the correct code has been written. And we'll repeat that. And so we'll be using testing here specifically in the chatbot project. I'll be giving you guys a test for this and we can go from there. Have a great day, and thanks.